Welcome back, and it's time for a demo. In this demo, you're going to implement a hybrid DNS system between AWS and a simulated on-premises environment belonging to the Animals for Life organization. Now, to allow you to get started with the demo lesson, the first thing you'll need to do is to create the base infrastructure, and you're going to use CloudFormation. That will create the AWS side on the left and the simulated on-premises environment on the right. Once the preparation steps have been completed, step 1 is that you'll need to verify there's no network or DNS integration between the two environments, and for this step, you'll be attempting to ping and resolve one side from an instance on the other, and then vice versa. Step 2 is that you're going to be establishing hybrid network connectivity. In the production setting, this might be using a direct connect, but for this demonstration, it will be simulated using a VPC peer. At this stage, the two environments will have network connectivity, but crucially, no DNS integration. Step 3 is where you'll configure the inbound integration, allowing the on-premises environment to resolve any DNS records which are stored within zones within the AWS environment. In this case, the zone is aws.animalsforlife.org. And then lastly, in step 4, you'll configure outbound endpoints and forwarding rules, and these will forward queries for the corp.animalsforlife.org DNS zone to the DNS servers which are in the on-premises environment. And that will allow both sides of this architecture to interact with the other from a DNS perspective. Now, it's a lot to do, but I'll be talking you through it step by step. So let's get started. Now, to get started, you'll need to be logged in to the general AWS account, so that's the management account of the organization, and as always have the Northern Virginia region selected. Now, attached to this lesson is a one-click deployment link that you can use to deploy the infrastructure that we'll be using. So go ahead and click on that link. That's going to take you to a quick create stack page, and everything should be pre-populated. Just scroll to the bottom, check the acknowledgement box, and then click on create stack. Now, you'll need this stack to be in a create complete state before you continue with the demo lesson. So go ahead and pause the video, wait for this to change into create complete, and then you're good to continue. Now, before you get started, attached to each lesson in this series is a full set of text-based instructions. So I do recommend that you open each of those links as you start each stage of this advanced demo, because that will make it much easier to follow along with all of the different pieces of configuration that I'm doing on the video. So definitely open those as you move through all of the different stages of this demo series. Okay, so this stack is now in a create complete status, which means that we've implemented this infrastructure that's on screen now. So the AWS environment on the left and the simulated on-premises environment on the right. Now what we need to do is to verify there is no networking or DNS connectivity between both of these networks. So to do that, go ahead and click on the Services drop-down and move to the EC2 console. Once you're there, click on Running Instances, and you should see a total of 5 EC2 instances. Now let's just expand the name column and then sort by name. Now you'll note that there are 2 instances which start with A4L AWS, and these are on the left side of the architecture, so the AWS side. You'll also have 3 which start with A4L-Onprem, and these are inside the simulated on-premises environment. Now, what I would recommend at this point is to wait until all of these instances show 2 out of 2 status checks before continuing. We just need to make sure that you don't have any problems connecting to these instances with Session Manager. If you do have any problems connecting with Session Manager, then you just need to wait a few more minutes and then try that step again. So the first step to verify that we don't have any networking or DNS connectivity is to connect in to one of the AWS instances. So let's select AWS-EC2-A. Right click on that one and put connect. Now these instances are inside a private-only VPC, but they do have SSM endpoints, and so you can connect to them using Session Manager. So go ahead and click on Session Manager, and then click on Connect. And this will directly connect you in to this EC2 instance inside this AWS VPC. Now once you're inside this instance, the first thing that I'll want you to do is to go ahead and test DNS connectivity. There's a server inside the simulated on-premises environment which is called app.corp.animalsforlife.org. So let's go ahead and try and ping that server. So ping space app.corp.animalsforlife.org. So go ahead and type that and press enter, and you should get a response back saying ping app.corp.animalsforlife.org, name or service not known. And that's as it should be, because there's no DNS integration between these two different networks. What we'll also try just to verify is we'll select the application server that we just tried to resolve, scroll down and just copy its private IP address into your clipboard. Now this IP address will be different for you, but it should start with 192.168.10. So copy that into your clipboard, move back to the EC2 instance, and then type ping and paste in that IP address. And you shouldn't get a ping response because there's no network connectivity between these two environments. So go ahead and close that tab down, and then we'll verify the reverse. So now select the Onprem-app instance, and this is the server that's running inside the simulated Animals for Life on-premises environment on the right of the architecture that we've been using. So right-click on this and put Connect. Again, select Session Manager and hit Connect. Now both of the EC2 instances running inside the AWS VPC, they're both using a DNS name of web.aws.animalsforlife.org. So let's try to resolve that address. So do a ping space web.aws.animalsforlife.org. So type that in and press enter. And you should get a name or service not known, because again, there's no DNS integration. Move back to the EC2 console and just select the AWS-EC2-A and again get its private IP address. Now this should start with 10.16, so make sure you've got the private IP address, copy that into your clipboard. Move back to the EC2 terminal and type ping space and then paste in that IP address. And again, you won't get a ping response because there's no network connectivity in addition to no DNS integration between these two different environments. So that's good. That's what we expect. So now we're at this stage and we've completed step 1 of the demo. The next stage is to establish the hybrid network connectivity between the AWS environment on the left and the Animals for Life simulated on-premises environment on the right. Now on this diagram it shows us using a direct connect, but for this demonstration we're going to simulate this using a VPC peer. So let's go ahead and do that. So to create the VPC peer, let's go ahead and close down this EC2 terminal, move back to the AWS console, click on the Services drop-down, and then in the Find Services box, just type VPC and click to move to the VPC console. Once we're there, click on Peering Connections on the menu at the left. Click on Create Peering Connection. For the peering connection name tag, just type AWS-Onprem, and this will indicate that it's a peering connection between the AWS environment and the simulated on-premises environment. Now the requester VPC will be the AWS side, so make sure you select the VPC that's called A4L-AWS. This should show a CIDR of 10.16.0.0/16. Scroll down and then for the acceptor VPC we're going to select the simulated on-premises environment. So click in the drop down and select A4L-Onprem, and this one should show a CIDR of 192.168.10.0/24. All being well, you should see no error messages and you can go ahead and click on Create Peering Connection. Now we're going to finish setting up this peering connection, so click on the Actions drop down and then click Accept Request. You'll see a confirmation dialog and you can go ahead and click on Accept Request. Now that's the peering connection created between the AWS environment and the simulated on-premises environment. Creating the peering connection itself is only one part of the process. We also need to configure the routing. And to do that, click on Route Tables under Virtual Private Cloud on the left. Now just expand the name column and you'll see two named route tables. We have A4L-AWS, which is the route table for the AWS VPC, and then we have A4L-Onprem, which is the route table for the simulated on-premises environment. And we need to edit both of these, adding a route for the other VPC. So first we'll select the AWS route table, select that one, click on Routes. There'll only be the local route for the CIDR range of that VPC, so we'll need to add another one. So click on Edit Routes and then Add Route. We're adding a route for the CIDR range of the simulated on-premises environment, and that's 192.168.10.0/24. So this is a route which allows the AWS VPC to communicate with the simulated on-premises environment VPC. So the target for this route, if you click on the target drop-down, is going to be a peering connection, and select the AWS-Onprem peering connection. And once you've done that, click on Save Changes. Hopefully everything's okay, and you can go ahead and click again on Route Tables. And then you need to follow the process for the simulated on-premises environment. So go ahead and select the on-premises route table, make sure that the Routes tab is selected, and then click on Edit Routes. This should have a local route for the CIDR of the simulated on-premise environment, that's fine. You'll also see another route for the S3 endpoint that's also in this VPC. Both of those are fine to leave as is. What you'll need to do is to click on Add Route, and we're adding a route which allows the simulated on-premises environment to communicate with the AWS VPC. So we need to add the CIDR range for the AWS VPC, which is 10.16.0.0/16. And again, the target is going to be the peering connection, so click on the drop-down, select peering connection, and then click on AWS-Onprem and save that route. And again, it should tell you that the routes have been successfully edited, and that's good. Go ahead and click on Route Tables. So now the network connectivity is in place between the AWS VPC and the VPC for the simulated on-premises environment. And what we need to do next is to test that. So to do so, click on Services and select EC2. Then click on Running Instances. Now you're going to need the IP address of one side of this newly connected network. So select the on-prem app server and then just copy the private IP address of this into your clipboard. Now note, this is on the simulated on-premise side of this newly integrated network. So what we need to do next is select an instance that's on the AWS side. So go ahead and select AWS-EC2-A. Right-click, Connect. Again, we're going to use Session Manager, so select that and click on Connect. So now if we type ping and then a space and then paste in the IP address of the app server and press Enter, we will now get a ping response. Now this indicates that we do have network connectivity, so layer 3 connectivity between the AWS environment and the simulated on-premise environment. What we don't have though is DNS integration. If we type ping and then a space, and then app.corp.animalsforlife.org and press enter, we still get name or service not known. So while we do have layer 3 network connectivity, we don't have any DNS integration. And that's what we're going to do next. Now the next stage of the demo lesson is to configure part 1 of the DNS integration. So what this means is to establish inbound integration from a DNS perspective. So this means that the simulated Animals for Life environment on the right can resolve DNS records that are stored on the DNS infrastructure inside the AWS environment on the left. Now to do that, we need to create some inbound Route 53 endpoints and perform some configuration updates within the DNS infrastructure on the right. So let's get started. So let's go ahead and close down some of these tabs. We'll only need the one tab open to the AWS console. Once there, click on the Services drop-down and type Route 53 and click to move to the Route 53 console. So the first step is that we're going to be creating some inbound endpoints. These are elastic network interfaces which will run in the AWS environment on the left of our architecture, and these can be used by our on-premises DNS infrastructure that's running on the right. So to create those, look on the left-hand menu under Resolver and click on Inbound Endpoints. Then click on Configure Endpoints. We're going to be configuring inbound only at this stage, so go ahead and click next to inbound only, and then click on Next. For the endpoint name, type A4L inbound, and then for the VPC, click on the drop-down and select the A4L-AWS VPC. These endpoints are going to be created in the AWS side of our infrastructure. You'll need to pick a security group that will apply to this endpoint. So click in the drop-down. This is how you can configure access to these inbound endpoints. So go ahead and select the AWS security group in that list. Under endpoint type, pick IPv4. And then inbound endpoints consist of 2 different IP addresses, and these IP addresses are owned by the network interfaces that are going to be created. So the way that we configure those is first, we need to pick an availability zone for this first IP address. So click in the drop-down and select US-East-1A, and then click in the subnet drop-down, and you should only see a single subnet. It should be called SN-private-A. Select that, and we're going to allow AWS to assign the IP addressing automatically. Scroll down further, and now we'll set up the second IP address for this inbound endpoint. So click in Choose Availability Zone, and then we're going to pick a different availability zone, so choose US-East-1B. Click in the subnet drop-down, and there should be only one subnet listed, so select SN-private-B, and again we're going to allow AWS to automatically assign the IP address. So everything else can be left as is. Scroll down, click on Next, scroll down to the bottom of the review screen, and then click on Submit. Click on Inbound Endpoints. Now that will take a few moments to create. Once it's finished, it should move into an operational state. Once it's in an operational state, then go ahead and click on the endpoint ID. You might need to scroll down depending on the size of your font, but it should list 2 different IP addresses for this inbound endpoint. These are the IP addresses that we're going to need in the next step, so note both of these down somewhere safe. Now that's the AWS side of this inbound integration completed. Now what we need to do is to make some configuration changes within the simulated on-premises environment. So to do that, you'll need to move back to the EC2 console. So either go to the tab which you already have open to the EC2 console, or open a new tab and go to Running Instances. We're going to need to make some changes on both of the on-premises DNS servers, so that's DNS-A and DNS-B. So go ahead and select DNS-A first, right-click, Connect, Session Manager, and then click on Connect. Now once you're connected, there's a file linked to this lesson called awszone.forward. Go ahead and open that in a text editor. And it's the configuration for a particular DNS zone, specifically AWS core.animalsforlife.org, which is the private Route 53 hosted zone that's running in the AWS part of our architecture. So what we need to do now is configure our simulated on-premises environment with this zone, and what this configuration will do is say that when any queries are happening inside the simulated on-premises environment, direct these queries at these forwarder addresses, and we're going to set those to be the IP addresses of the Route 53 inbound endpoints that we just created. So go ahead and select Inbound Endpoint IP1. So select everything from the I of inbound all the way to before the semicolon. So it should look something like this. And I want you to replace that with the first IP address of the Route 53 inbound endpoint. Now you should have noted this down earlier. So make sure that you've got your first inbound endpoint IP address in your clipboard, and then replace this placeholder. So it should look something like that, only with your IP address. Do the same for inbound endpoint IP2. Start with the I and then end before that semicolon. You'll need the second IP address. So copy that into your clipboard and just paste that in. Once you've made those changes, select everything in this file, making sure that you do have everything selected, and copy that into your clipboard. Then move back to the AWS console, and you should still have the session open to the first DNS server. So this is this DNS server, DNS-A. Now there's a DNS server that's running on this Linux instance, and we're going to edit its configuration files. So they're stored in the etc directory. So type cd /etc and press enter. And we're going to edit one of its configuration files. So we need root permissions to be able to do this, so type sudo nano, which is a text editor, /etc/ and then the name of the config file that we're changing, which is the config file for the DNS server. This is called named, so named.conf. So type that in and press enter. And this is the configuration file for the DNS server that's running on this Linux machine. So what we're going to do, go all the way down to the bottom of this file. Note how directly above where your cursor is, there's the zone configuration for the corp.animalsforlife.org zone. So this is the DNS zone that's running inside the simulated on-premise environment. And what we're about to paste in is the configuration for the zone that's running inside the AWS environment. So paste your clipboard into this file. So what this does is it tells this DNS server whenever there are any queries for aws.animalsforlife.org, forward them to these two IP addresses. And of course these are the Route 53 inbound endpoints that you've just set up. So do a Control-O and then Enter to save this file, and then a Control-X to exit. Now in order that this DNS server reads in this configuration file, we're going to do a restart. To do a restart, we just need to do a sudo service named, so named, and then a space, and then restart. So do that and press enter. Now that we've restarted the DNS service, it's loaded the config file into memory, and now it should be active. So now, just to test that, before we do the same process on the other DNS server, we'll use the command nslookup, and this allows us to perform DNS lookups. So type nslookup and press enter. We need to tell it what server to use, so we'll type server 127.0.0.1, which means the local host, so this local server. And then we're going to make sure that it can now perform a lookup from the AWS environment, and this is using the Route 53 inbound endpoints. So it's talking to this local server, and then this local server is forwarding those queries across to the AWS side. So to test that, type web.aws.animalsforlife.org and then press enter. And if that's successful, you should get an answer. And architecturally, the way that this works is this query is going to the local DNS server on this Linux instance. From there, because we've added that piece of configuration for the aws.animalsforlife.org zone, it's forwarding those queries to the Route 53 inbound endpoints, and they're being used to query the Route 53 resolver, and the Route 53 resolver has that information because the CloudFormation templates have created a private hosted zone. So if we go back to the AWS console, go to hosted zones, we've got the aws.animalsforlife.org hosted zone, which was created by the CloudFormation template. And in there, we've got one single record called web.aws.animalsforlife.org, which points at both of the EC2 instances inside the AWS environment. And that's what we've just performed a query against. So we've retrieved both of the IP addresses for both of the EC2 instances that are running inside AWS. Now, to complete that process, close down this server. We need to do the same on DNSB. So right-click, connect, session manager, connect. Just make sure you've got this zone file configuration still in your clipboard. Go into the etc folder, and then with root permissions, so sudo space, nano space, /etc/named.conf. Go all the way down to the bottom of this file, paste that configuration in, save that file by pressing Ctrl-O, exit by pressing Ctrl-X, and then restart the DNS server by typing sudo space service space named, which is the DNS service, space, and then restart and press enter. And now we've got the same configuration on the second DNS server. Now that these two on-premise DNS servers are configured to forward queries through to the Route 53 inbound endpoints, in a production environment, the next thing that you would do is configure all of your on-premises servers to use these DNS servers. So let's do that. Select the on-premises app server, again, connect, session manager, click on connect. Now, the way that we can configure this Linux instance to use explicitly provided DNS servers is by editing a configuration file. To do that, we need root privileges, so sudo space, nano space, and then /etc/systemd/resolved.conf, and press enter. Now what we need to do here is specify the DNS servers that this instance is going to use, and we need to specify the two on-premises simulated DNS servers. So those are the ones running on EC2. So scroll down to the bottom of this file, and then right at the bottom add DNS in capitals equals, and then we need to put in some IP addresses. To get those, go back to the EC2 console and instances, and we need to paste in the private IP addresses for both the A4L on-prem DNS A and B. So let's start by selecting DNS A, and then copying down the private IP version 4 address into your clipboard, then move back to Session Manager and paste that in, and then add a space. Then go back to the EC2 console, select DNSB, copy down the private IP address into your clipboard, go back to Session Manager, paste that in as well. Then move one line down, and now we need to enter domains with an uppercase D equals ~. So just type what's on screen now, and that will adjust the configuration of this EC2 instance. So instead of using the default DNS servers, it's going to use the simulated on-premise DNS servers that you've just configured. So press Ctrl-O and Enter to save this file, and then Ctrl-X to exit. And then we need to reboot this EC2 instance. So do that with sudo space reboot. You'll need to wait a couple of minutes for this to fully restart. Once it has, you should be able to select A4L-onprem-app and right-click, go to Connect, choose Session Manager, and click Connect. Once you're at the terminal, you should be able to type ping space web.aws, because we're querying the AWS side, dot, animalsforlife.org and press enter, and you should now get both DNS resolution and a ping response. The reason for this is we've now got network connectivity between the simulated on-premises environment on the right and the AWS environment on the left, but we've also configured the inbound integration. So the DNS servers that are running within the simulated on-premises environment have been configured to forward queries through to the Route 53 inbound endpoints, and that's how we can get a result to our query, how we can retrieve the IP address, and that's what's used for these successful ping responses. So we've now done the inbound component of this demo. Okay, so to configure the outbound component of this integration, let's move back to the Route 53 console and select Outbound Endpoints towards the bottom left. And we're going to create an outbound endpoint. We'll call the endpoint name A4L Outbound. This will also be running from within the AWS component of our architecture. So click on the VPC dropdown and select A4L-AWS. It's also going to need a security group, which is how we can secure these endpoints. So click in the drop-down and select the AWS security group, and then select IPv4 under endpoint type. The outbound endpoints will use two IP addresses, so scroll down, select availability zone 1A, pick the private A subnet, and we'll let AWS assign the IP address automatically. For IP address 2, select 1B, choose private B subnet, and again, we'll allow AWS to assign the IP address automatically, and then click on Create Outbound Endpoint, and this is creating the outbound Route 53 endpoint. Again, this will take a few moments to create, so we'll need to wait for that process to finish. So go ahead and pause and wait for it to move out of the creating status. Once that finishes creating, it should show as operational, and next we need to configure the forwarding rules that will use this outbound endpoint. So go ahead and click on Rules towards the bottom left, and we're going to create a rule. We're going to call the rule A4L Onprem -corp zone so that we know the role that it provides. And then scroll down, and under domain name, we need to configure the domain name that this rule will forward queries for. So we need to use the zone that's located within the simulated on-premises environment. So this is corp.animalsforlife.org. So type that in. And then we need to pick which VPCs will use this rule. So it's going to be A4L-AWS. We want this rule to apply to all services within the AWS VPC. And then we need to pick the outbound endpoint that this rule will apply to. So click in the drop-down and select the A4L outbound endpoint that you just created. Now this rule is going to forward any queries for this domain name, and we need to pick where those queries are forwarded to. So we need to give two IP addresses. So click on Add Target, and we need to provide the private IP addresses of the DNS servers that are running within the simulated on-premises environment. So go back to the EC2 console, and we need the private IP addresses for onprem-DNS-A and onprem-DNS-B. So first, let's do DNS-A. So copy that into your clipboard. Move back to the Route 53 console and just paste that into the top IP address box. Go back to the EC2 console, pick DNS-B. Copy that into your clipboard, and paste that into the second IP address box. So what this is doing is it's going to forward any queries for corp.animalsforlife.org through to these two IP addresses. And these, just to reiterate, are the DNS servers running within the simulated on-premises environment. So go ahead and click Submit. That rule's applied and it's now active. So let's go back to the EC2 console, and we're going to test it by connecting to one of the AWS resources. Let's use EC2-A. Right click and select Connect. Choose Session Manager. Click on Connect. So now we're inside the AWS environment, and let's ping a resource inside the simulated on-premises environment. This will test the network connectivity and the DNS resolution. So type ping, space, app, so app, .corp, C-O-R-P, dot, and then animalsforlife.org, and press enter. And now that we've configured the integration, it will resolve this name to this IP address, and because of the connectivity that we have between the two environments, that ping will return a response. So the architecture of this is that this query originates inside the AWS environment. It goes to the Route 53 resolver. Because we have those rules in place, the Route 53 resolver knows for any corp.animalsforlife.org queries to use these particular outbound endpoints. And then these outbound endpoints are used to forward that query through to the DNS servers running inside the simulated on-premises environment. And those are the servers that are providing an answer to the DNS query that we've just run as part of that ping. So we get the IP address back in response to that query, and then we can ping that IP address. And at this point, you've successfully configured integration in both directions between these environments. So you've configured inbound integration from the simulated on-premises environment into AWS using inbound endpoints, and you've configured the reverse, so integration from AWS to the simulated on-premises environment using outbound endpoints. And that's everything that I wanted you to do in this demo lesson. I hope it's been useful and you've gained some practical experience of how to perform a fairly complex integration of AWS and on-premises DNS environments. At this point, all that remains is for you to tidy up to put the accounts back into the state as they were at the start of this demo. So to do that, move back to the AWS console, select Rules, and then click on the rule that we've just created. It should be called A4L Onprem-Corp Zone. Select the VPC that it's associated with and select Disassociate. Now that will take a few minutes, so just pause the video and wait for that to finish disassociating. Once that has disassociated, then we can go ahead and delete the rule by clicking on Delete. This time you'll need to type delete. Once the rule's deleted, then you can go to outbound endpoints, select the outbound endpoint and click delete. Again, you'll need to type or paste delete into that box. Do the same for inbound endpoints, so select the A4L inbound, click on delete, type delete. Next, we'll need to delete the VPC peer, so click on the services drop down and select VPC. Click on peering connections. Make sure the VPC peer that you've got selected is the one between the AWS environment and the simulated on-premises environment. Click on the actions drop down, delete the VPC peering connection. Now, a new option with the recently updated console is you can actually select to delete the route table entries that you've created for this VPC peer as part of deleting the peering connection. So you can select delete related route table entries, and that will cause it to delete those entries when you delete the peering connection. Now I'm going to show you the process manually, so go ahead and click Do Not Delete the Route Table Entries. You'll need to confirm the deletion by typing delete into this box and then clicking on delete. And once you've done that, go ahead and click on route tables. And we need to edit both of these, so select the on-prem one, click on routes. We're going to remove these black hole routes, so click on edit routes. Click on remove next to black hole, click on save, then select the other one. Again, routes, edit routes, click on remove next to black hole, and click on Save Changes. Now we did both of those because we edited those route tables to point at the VPC peer, which no longer exists, and so we just want to make sure that we return those route tables into the same state that they were when they were created by the one-click deployment at the start of this demo series. And then the last step, click on Services, select CloudFormation, and we're going to delete the stack Hybrid DNS, so select it. And this is the stack that was created using the one-click deployment. So select that stack, click on delete, and then delete stack. And once all of that's finished, your account will be back into the same state as it was at the start of this lesson. With that being said though, that's everything you need to do for this demo lesson. I hope it's been enjoyable, and I hope it's given you some good practical experience of how to operate with Route 53 endpoints. So go ahead, complete this lesson, and when you're ready, I'll look forward to you joining me in the next.